Okay, let's shoot another video on 11.9. So last time we learned that you could take a function like 1 over 1 minus x and turn it into, what's it, 1 plus x squared plus x cubed plus dot dot dot. And this and that were exactly the same. What's better about this one is this a polynomial. It's easier to deal with. What's not better about this one is it's got an infinite number of terms. And I could, if I want to integrate this, I can integrate it. If I want to differentiate that, I can differentiate that. It's a lot easier than working with this guy. But this one only worked for inside this guy's radius of convergence. So if you define f of x equaling 1 minus x and say, okay, well, I can just say f of x is equal to 1 plus x squared plus dot dot dot. And then you say, what's f of 2? Well, that works in this guy. It doesn't work in this guy because this guy's radius of convergence is 1. And so its interval of convergence is between the ones. It only works from -1 to 1, not including the ones. So, and then we took derivatives and integrals, and how do I know that this radius, what's its radius of convergence? Real quick, what would the radius of convergence, suppose I got, I know that 1 over 1 minus x is equal to 1 plus x squared plus dot dot dot. This guy's radius of convergence, I gotta have x is less than 1, so its radius of convergence is 1, and its interval convergence is -1 to 1. Suppose I created one by doing x minus 4x squared. Okay, well, I'm assuming that's equals to 1 plus, instead of x, I got this guy, so that's going to be 4x squared plus 4x squared squared, so that's going to be 16x to the 4th plus, and then the math is getting beyond me, just keep doing the same thing. Get some, what's this radius of convergence? Well, it says that 4x squared in absolute values has to be less than 1 for this to work, and now we're using this inside of that. So that's going to say that a -1 is less than 4x squared is less than 1. Well, 4x squared, that's all positive, so it's always going to be bigger than 0. I'm going to divide by 4, so I got 4. Oh no, I killed it before. I got x squared is less than 1/4 is bigger than 0. And now I want to square everything, but squares I get a plus and minus here, so that's going to x will be between the halves in this case. So a negative half would work all the way up to a positive half, not including the halves. If I'm going to use this, so this guy's radius of convergence would be a half, and its interval would be -half to half. And so that's where that guy would work on. So if I defined f of x to be this function, it would only work in that spot. Okay. So now I'm going to lay some stuff down and give you a big theorem. So we got power series. You can define a power series, you know, n equals 0 to infinity of an xn, or you can shift it off center. N equals 0 to infinity of an x minus c. So that's got a center at c. This guy has a center at 0. All the things I'm fixing to show you work for either one of these. This one's just easier to write down with this small board, so I'm going to work on this guy. So we're going to, again, everything I'm fixing to say, we'll work on this guy too, where its center is moved off of 0. But we're going to find f of x equaling the sum n equals 0 to infinity of an xn. Okay, so we got some function that we wrote out as a power series. Now, if we look at this guy right here, it's a polynomial, so I can differentiate it. So the derivative of f exists. If the derivative of f exists, that means it's continuous. The function is differentiable, it's also continuous. So this function defined as power series is continuous. It is differentiable and it's integrable. I can take its integral. All right, well, what would those look like? So what's the ddx of f of x? Well, let's write this guy out. So that's 1 plus x squared plus x cubed plus, and going forever. Can we figure out what that is? What's the derivative of this guy? Nothing. He's gone. That's 0. What's the derivative of this guy? That guy's 1. What's the derivative of this guy? That's 2x. What's the derivative of this guy? 3x squared. What's the derivative of the next guy? It'd be 4x cubed. So how would you write that down as a sum? Sum equals n equals what? Where does n start? And I got to get it to look like this. Is that going to be n? So if I wrote n x to the n minus 1, remember when he had this guy, he brought it down and he took 1 off. Okay, and then I left something off. I needed these a-n's here. These a-n's were constants. Back up a bit. When I wrote that down, I wrote it like this. It kind of works, but I left these guys off. At least it got you started. It looks like that. What's going to happen? I need to put my a-n's on there. But let's start over. So that's going to be a0 plus a1 plus a1 what? a1x plus a2x squared plus a3x cubed plus dot dot dot. Take the derivative of that. A0 is a constant. Take the derivative of this guy, so that goes to 0. This guy goes to a1. This guy goes to 2a2 x to the first power plus 3a3x squared plus 4a4 x cubed. So if you look, this is going to be you got a 2 here, so you're going to get, that's going to be your n, so I got an n, that's going to be a to the n, but my x is going to be 1 smaller, so that's going to be x n minus 1. What does it look like? I brought down my n and took 1 off of it, just like a regular derivative. Now where am I starting? Remember, I killed the first one, so I'm not going to start with 0 now, I got to start with 1 and go to infinity. Just make sure this works. Plug in a 1, you get 1 x to the 1 you get 1 a1 x to the 1 minus 1 is x to the 0, so that turns to a 1, which is this guy. Next one, you're going to get 2 a2 2 minus 1, so you're going to get 1x. So that's the derivative of this. What about the integral? Okay, so let's take the integral of f of x dx. Okay, let's write this guy. Let's write down right this time. So that's going to be a0. So f of x equals a0 plus a1x plus a2x squared plus a3x cubed, and I keep going on forever. So integrate that. What happens when you integrate a constant? So we integrate this. Integrate a constant, integrate all these guys. Integrate a constant, so that's going to be the constant times x. Plus you get the constant, and now I'm going to get x squared. Remember, we got to divide by 2. And then we're going to get the constant, which is a2, and we'll raise the power x3, but we're going to divide by 3. And then plus a 3x to the 4th over 4. And if you don't like that, take the derivative. What's the derivative of a0x? It's a0. Take the derivative of this, bring the 2 down, it's going to kill that 2. You know, a1x, bring the 3 down, it's going to kill that 3. The 3 is going to turn into a 2, I'll get this guy. Okay, so what's the integral of this thing look like? Summation n equals 1 to infinity. I'm not sure if it's 1 or not. And let's see how we write this. Okay, just pick this one. So the number on bottom is bigger than the a. So I'm going to have, if I got a n, I'm going to divide it by a, if this was a 1, that's got to be a 2. How do you make it a 2? Add 1 to it. And then you're going to have x to the n plus 1. Well, what did you do when you integrated stuff? You added 1 to the exponent and you divided by the exponent. Okay, so that's what the integral of this power series looks like. So if I'm given a function defined as a power series, it will have a radius of convergence. That function will be continuous, it'll be differentiable, and it'll be integrable. Now this guy will have a radius of convergence. And all of these will have, and they'll have this, don't get me wrong here, they will have the same radius of convergence. Now, whether on the this guy might work on the endpoints, this guy might not work on the endpoints, but this one will work on all the interior of the interval. This one will work on the interior, this one will work on the interior. We're not sure if they match up on the endpoints. If you don't look at the endpoints, you have to do those separately. Okay, so Give me a function defined as a power series. I can take its derivative, I can take its integral. They'll have the same radius of convergence. The interval will be almost the same. I'm just not sure about the endpoints of that interval. Let's look at a couple examples. Okay. Here's one use we might have of this. Now, in your homework assignment, and later on, we're going to do E. A lot. This is going to be the one we use a whole bunch. E ends up being n equals 0 to infinity of x to the n over n factorial. So what does that look like? Put in a 0. 0 factorial is 1, and n to the 0 is 1, so you get 1 plus x over 1 factorial, and 1 factorial is just 1, plus x squared over 2 factorial, plus x cubed over 3 factorial, plus x to the 4th over 4 factorial, plus it goes on forever. So this thing's equivalent to E. What's nice about this guy, the radius of convergence of this guy, or the interval convergence, is minus infinity to infinity. So this guy always works. And you're going to use this a lot when you get to differential equations. Why is E used a lot in differential equations? Because when you take the derivative of E, what happens? Nothing. Take the integral of E, what happens? Nothing. So I like in differential equations, we're going to be working with differentials, and I like stuff where nothing happens. In algebra, one of my two favorite numbers. 0, because when I add 0, what happens? Nothing. 1, because when I multiply by 1, what happens? Nothing. Now, I often Cal 1, they use this example, they tell you to take the integral of this. And you can't do it, because there is no, they call it the Irv function, but it just means they don't know how to do it. So, I don't have a good antiderivative for this guy. But what if I wrote it as a power series? So could I take the integral of 1 plus, that's going to be x, plus x squared over 2. That's going to be x cubed over, that's 6, plus x to the 4th over 24, plus x to the 5th over 5 factorial, which is 120, plus dot, 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 the x. Could you integrate that? Yes, each one of these guys are really easy to integrate. Problem is they got an infinite number of them. How many of these guys do I need to take it out to get a nice answer? I mean, give me an answer that I have an area that I can work with. So here's a nice example. I took a function. We'll learn how to create the power series representation for E, and then I can integrate e to the x squared because it's just a polynomial. Okay, I'll stop there. You do your homework.